Okay, so we are in Chapter 9, Section 3, and now we're talking about parabolas. Now, you're used to graphing parabolas vertically, and we can talk about the vertex and the axis of symmetry, and we can talk about all of those things, whether it's positive or whether it's negative. In this section, we're also going to look at horizontal parabolas. Now, if my vertex is at the origin at 0, 0, then these are the formulas that I'm going to be using. And it looks a little bit different than the formulas you might be used to. Typically, you have y by itself and then x squared and some other terms over here. But this is the format that we'll use for a vertical parabola, and this is for a horizontal parabola. And this p-value here is going to give us a lot of helpful information. Now, if these are my graphs here, this would be my horizontal parabola, and here's my vertex like we're used to. And the distance p here is the distance from our vertex to the focus, and then from the vertex to what's called the directrix. Now, the definition of a parabola is the set of points that are the same distance from a point and from a line. So what's nice about this graph is that every single point along this curve here is the same distance from this point as it is from this line. So if I draw any random point on this graph here, the distance from my focus to the distance of my directrix, these distances will be the same. The same is true in a vertical parabola. So my focus, my directrix, this line right here, and this is my parabola, my vertex right here. Again, these distances are the same, and that distance is this p-value from our equation. Let's go ahead and flip the page and look at the next thing here. Now, there's some other information that we can gather from this p-value that will allow us to not have to plug in points in graphing this parabola. The p-value here in our equation is called the latus rectum. We'll call it the LR. Okay? And this length right here is this distance right here. So through the focus, if we draw a line the length of 4p, then we can draw our curve with those endpoints. So no longer having to make a table of points or plugging anything in. Now let's go ahead and dive in and get right to some examples here. Looking at our first one, it says find the focus and the directrix for the parabola given. And looking at this, I can tell that this is going to be a vertical parabola, because x is squared and y is by itself. And then we're going to go ahead and graph it. So this is x squared equals 4py. So what we're saying here is that 4p is equal to negative 8. Well, 4p equals negative 8 gives us that p is equal to negative 2. So from this, we can tell that our graph is going to be going down since our p-value is negative. So my graph is going down. And we do need to graph this, so I'm going to go ahead and start using some information here. Now, we said this is a vertical parabola, and it's going down. And our vertex is at the origin, and from here it's going down. My p-value is 2. And the length of my LR is equal to the absolute value of 4p. Well, in this case, that's going to be the absolute value of 4 times negative 2, which is 8. Now, the only other thing I need to find is my focus. Well, my p-value is negative 2, so my focus is 2 here. This is my vertex, and my directrix is going to be up 2. It's that p distance here. So this distance is p, and this distance is p. So that tells us enough information now to graph. We have our vertex, focus, directrix, and we know our LR is 8. So through the focus, we're going to draw a line, a length of 8. 4 to the right, 4 to the left, and that gives me my parabola. So we're done with that one. Oh, we do need to state the focus and directrix. So my focus was the point 0, negative 2. My directrix is the horizontal line y equals 2. Okay. So let's look at the next one. It says find the standard form of the equation of a parabola with focus 5, 0 and directrix -5. Well, let's actually look at what those are. Now, it's not asking us to graph, so I'm just going to draw a quick sketch of it. But 5, 0, 1, 2, 3, 4, 5, that's my focus. 1, 2, 3, 4, 5, x equals -5, that's my directrix. So my center has to be right in the middle of that. So my vertex is at the origin. And it's not going to curve this way because our parabola is not going to cut through the directrix. So this has to be a positive horizontal parabola. So if it's a horizontal parabola, then we have the equation y squared equals 4px. And we know that our p-value is the distance from our center or our vertex to the focus, or this distance right here, and that would be 5. And we know it's positive because it's curving in a positive direction. So we have y squared equals 4 times 5 is 20x, and that's the equation of our parabola. So let's go ahead and flip the page onto the next example. And on this page we see some more information here. We're looking at all the different information for parabolas that now maybe the vertex is not at the origin. So our vertex is going to be at HK, and these are our new equations right here. This is whether it's horizontal or vertical. And we can find our focus and our directrix this way, or we can just use the p-value and the graph. Now let's go ahead and look at our last example here. It says find the vertex and focus and directrix of the parabola given. So we need the vertex, the focus, and the directrix. And this is our graph right here. Now because x is squared, this tells me that it's going to be vertical. And my p-value is positive, so it's going up. So we know that much information. Now the general equation here is x minus h squared equals 4py minus k. So then hk is my vertex, and in this case that's going to be 3, -1. So let's go ahead and just start graphing some of this information here. And we have 1, 2, 3, 4, 5. And we said that our vertex is at 3, -1. And then we can go ahead and find our focus. Because this is vertical, in order to find my focus, I'm going to go up the distance of p. And here we have 8 is equal to 4p, so p equals 2. So I'm going to go up 1, 2. So my focus is at 3, +1. And my directrix I can go down 2. So that will be y equals -3. So I found those 3 pieces. Now I just need to finish my graph. If my p-value is 2, then the LR is going to be through the focus, and it's going to be a distance of 4 times 2 is going to be 8. So I'll go half of that in each direction. So I have 1, 2, 3, 4. 1, 2, 3, 4. And there we go. And that's the graph of my parabola. And that is going to be the end of section 3.